For 37 years, Uranus had everyone fooled. It sat out there at the edge of the solar system, a smooth, quiet, pale blue marble. And we believed the disguise. We called it boring. We called it the planet nobody wanted to visit. Then, the James Webb Space Telescope turned its eye on it, looked at it in a kind of light our eyes can't see, and the calm blue marble vanished. What stared back was something else entirely. The last time a human machine got a real look at this planet was January of 1986. Voyager 2 made its closest approach on the 24th of that month, sweeping within about 50,000 miles of the cloud tops, snapping its photos and continuing on into the dark. And the photos showed almost nothing. A featureless ball. No storms, no bands, no weather, no drama. For an entire generation, that single bland portrait was the whole story of Uranus. Webb just rewrote it. There's a detail in those old Voyager images that nobody dwelled on at the time, and it should have been a warning. The planet was never calm. It was hiding. And once you understand what it was hiding, the silence in those pictures stops feeling peaceful and starts feeling like the stillness of something that doesn't want to be noticed. To understand why Uranus is the way it is, you have to go back to the night it was found. The year was 1781. A musician turned astronomer named William Herschel was sweeping the sky over his backyard in England with a homemade telescope when he caught something that wasn't behaving like a star. At first, he thought it was a comet. It wasn't. It was a planet. The first planet in human history ever discovered with a telescope rather than the naked eye. Every world known before that night had been visible to ancient people for thousands of years. Uranus was the first one we had to go looking for. And that's fitting, because from the very beginning, this planet has only ever given up its secrets when forced to. Now, let me get to the part that breaks your brain, before we even reach the cold, or the smell, or the rain. Uranus is lying down. Every other planet in the solar system spins more or less upright, like a top on a table. Earth leans a comfortable 23 degrees, which is why we have seasons. Uranus is tilted almost 98 degrees. It isn't spinning, it's rolling. Picture a bowling ball rolling down the lane instead of a top spinning on a table, and you've got the right image. This planet got knocked completely onto its side at some point in its ancient past. Almost certainly by a collision with something enormous, and it never got back up. That single fact poisons everything else about the place. Because when a planet lies on its side, its poles don't point out to the sides. They point at the sun, one at a time, for decades. Picture what that actually means if you were unlucky enough to stand there. Uranus takes 84 years to go around the sun. Lying on its side the way it is, one pole gets aimed almost straight at the sun and bakes in continuous daylight for about 21 years. No sunrise, no sunset, just a dim sun nailed to the same spot in the sky, going in slow circles, never setting for 2 decades. And on the opposite side of the planet, the other pole is doing the reverse. 21 years of solid darkness. A winter with no morning. If you were born on the wrong hemisphere at the wrong time, you could live a full human life, grow up, grow old, and die without ever once seeing the sunrise. and the sun out there wouldn't be much comfort anyway. Uranus sits about 1.8 billion miles from the sun. At that distance, sunlight is roughly 400 times fainter than what you feel on a bright afternoon here. Noon on Uranus is dimmer than the moment right after the sun dips below the horizon on Earth. It's a planet living in permanent dusk. So we've got a world rolling on its side in near darkness. Now the temperature, because the cold is where Uranus stops being merely strange and turns openly hostile. Uranus is the coldest planet in the solar system, not the farthest, the coldest. And those are not the same thing, which is one of the genuine mysteries here. Neptune is farther from the sun, yet Neptune runs warmer. Uranus is the deep freeze. The temperature in its upper atmosphere drops to about minus 371 degrees Fahrenheit. Human language runs out of words for cold long before you reach a number like that. The coldest temperature ever recorded on Earth, in the middle of the Antarctic plateau in the dead of winter, was about minus 128 degrees Fahrenheit. Uranus is colder than that by more than 240 degrees. It is not a little colder than the worst night Antarctica has ever known. It is so far beyond it that Antarctica, the most lethal cold a human being has ever measured, would feel almost warm by comparison.
Why is the farther planet warmer than the closer one?
Honestly, nobody has nailed it down. The leading idea points back to that ancient collision. The same hit that knocked Uranus on its side may have also shut off or trapped the leftover heat in its core, leaving it leaking almost no warmth from within. Neptune still glows with internal heat, radiating more energy than it gets from the sun. Uranus barely does. It's a planet that seems to have had its furnace switched off 4 billion years ago and has been quietly freezing ever since. You'd think the cold would be the worst of it. It isn't. Because if the cold somehow didn't kill you instantly, the air would, and it would do it in a way that feels almost like a cruel joke. In 2018, astronomers using a telescope in Hawaii finally cracked a secret the planet had kept even from Voyager. They figured out what the clouds are made of. The upper clouds of Uranus are rich in hydrogen sulfide. That's the gas that gives rotten eggs their smell. So, if you could somehow stand in the cloud tops of Uranus and take a breath without your lungs freezing solid, the first thing you'd register, before the cold and the suffocation finished you, is the overwhelming stench of rot. The whole planet smells like a cracked egg left in the sun. The scientist who led that discovery put it about as bluntly as a scientist ever does. He said an unfortunate human descending through those clouds would meet very unpleasant and odoriferous conditions, but the suffocation and the cold would take their toll long before the smell ever got the chance to bother them. That's Uranus in a single sentence. It will kill you several different ways at once, and the rotten egg smell is just the planet's idea of an insult on the way down. We still haven't gotten to what's underneath the clouds. We will. It's stranger than the surface, and in a way, it's the strangest thing in the entire solar system. But everything I've told you so far was assembled piece by piece over decades, from one flyby and a handful of ground telescopes squinting across 2 billion miles. Webb changed the resolution on all of it at once, and to understand why that matters, you have to understand what Webb actually does differently. When the James Webb Space Telescope looked at Uranus, it didn't use visible light, the kind your eyes use, the kind that made Voyager's photos look so dead. It used infrared, heat light, the light that leaks out of things and reveals what they're actually doing. And in infrared, the calm blue marble lit up like a crime scene under a black light. the smooth blue ball was gone. In its place was a world with structure, motion, and weather. There was a giant bright cap sitting over the North Pole, a vast white hood of haze that wasn't visible before at all. Right at the center of that cap, Webb found a bright spot that turned out to be the heart of an enormous, swirling vortex. A storm system anchored over the pole, warmer than the air around it, churning. Bright storm clouds were scattered around the edge of the cap, the kind of weather we'd been told this planet didn't have. The dead, featureless world from 1986 was, it turns out, alive with motion the whole time. We just didn't have eyes good enough to see it. And the timing of all this is not an accident. The planet is creeping toward its solstice in the year 2028, the moment its north pole points most directly at the sun. As that pole drinks in more and more sunlight, the polar cap is brightening, growing, changing in ways no one has ever watched in real time. Webb is recording the whole transformation, season by season, trying to crack why that cap appears when the pole turns toward the sun and fades when it turns away. We are, for the first time, watching the seasons turn on a planet where a single season lasts longer than most human careers. Then there are the rings. Most people don't even know Uranus has rings. They're nothing like Saturn's bright, showy bands. They're thin, dark, and faint, made of nearly black, dusty material, almost impossible to see. Voyager spotted them as it flew past. After that, only one observatory on Earth, the Keck telescope in Hawaii, had ever managed to image them clearly. Webb captured 11 of the planet's 13 rings in a single shot, crisp and glowing, including one called the Zeta Ring, the faintest and most elusive of them all, a ghost of a ring hugging close to the planet that we'd barely confirmed existed. But the rings don't lie flat like Saturn's. Remember, the whole planet is tipped on its side, so its rings are tipped too. Instead of circling the planet's waist like a belt, the rings of Uranus stand up vertically, like a giant bullseye, a target painted around a world rolling through the dark. Webb caught that orientation perfectly, and it is one of the most quietly unsettling images in all of astronomy. A planet doesn't tip itself over. Something out there did this to it, and the sideways rings are the fingerprints left behind. Webb didn't stop at the rings. It went hunting for moons, and here's where this telescope did something Voyager never could. As of right now, Uranus is known to have 29 moons, and that number went up because of Webb. In early 2025, a team studying Webb's images spotted a tiny new moon, only about 6 miles across, tucked in close to the rings. It's so small that when Voyager 2 flew right past it in 1986, the spacecraft's cameras never even saw it. A moon hiding in plain sight for the entire span of the space age, and it took the most powerful telescope ever built to finally catch it. The same instrument that exposed the planet's weather is still finding pieces of its family we didn't know were there. The moons of Uranus aren't named after gods like most of the solar system. They're named after characters from Shakespeare and the poet Alexander Pope. Titania, Oberon, Miranda, Ariel, Umbriel, Puck. A whole frozen court of literary ghosts orbiting a sideways king in the dark. And one of them, Miranda, hides something that belongs in a nightmare. Miranda is small, less than 300 miles across, and from a distance it looks like a scuffed, dirty snowball. But carved into its surface is a cliff called Verona Rupes, and it may be the tallest cliff anywhere in the solar system. It drops something like 12 miles straight down. For comparison, that's more than twice the height of Mount Everest, standing as a single sheer wall of ice. Now picture this. Miranda's gravity is so feeble that if you stepped off the edge of that cliff, you wouldn't plummet. You'd fall slowly, almost gently, tumbling through the silence for somewhere around 10 minutes before you finally reach the bottom. 10 full minutes of falling,
in total darkness, off the highest cliff humanity has ever found, on a moon orbiting the coldest planet we know. There's no scream out there, no air to carry it. Just the slow, quiet, patient fall. So why does any of this matter beyond a few pretty pictures? Because of what it tells us about the rest of the universe. When we look out at other stars and count the planets orbiting them, a huge number of the most common worlds we find are roughly the size of Uranus and Neptune. Not giant gas balls like Jupiter, not small rocky planets like Earth. In between. Cold, hazy, hostile worlds, much closer in kind to Uranus than to home. Which means this planet, the one we dismissed and ignored, may be the closest example we have of the most ordinary planet in the galaxy. We used to think Uranus was the oddball of our solar system. It may turn out to be the standard, and Earth the rare exception. Now we go down, past the clouds, past the rotten egg haze, into the body of the planet itself, because the surface is a magic trick, and the real horror is underneath. Uranus doesn't have a solid surface you could ever stand on. If you try to fly a ship into it, you wouldn't crash. You'd sink. The atmosphere would just get thicker and thicker, the pressure climbing with every mile, until it crushed your ship like a soda can underfoot, and you kept right on falling into a substance that isn't quite gas and isn't quite liquid. There is no ground. There is no bottom you'd recognize. Just an ever-thickening soup that swallows everything that enters and never gives it back. Go deep enough and you reach the mantle, and what's down there is hard to believe, even for the people who study it. Most of Uranus, the bulk of the whole planet, is a vast, hot, dense ocean. Not water like our oceans. A scalding, churning fluid of water, ammonia, and methane, compressed under crushing pressure, electrically charged, with no surface and no shore. An ocean thousands of miles deep that wraps the entire core of the planet, hotter than the surface of some smaller stars, yet locked under so much pressure it can never boil away. You couldn't drown in it. You'd be crushed and cooked long before the question of drowning came up. And then there's the rain. Deep inside Uranus, scientists believe it rains diamonds. I'm not being poetic. The methane in that deep ocean is loaded with carbon. Squeeze carbon hard enough and heat it just right, and it crystallizes. The pressure miles down inside this planet is exactly the kind that wrings the carbon out of the methane and presses it into solid diamond. Those diamonds, heavier than the fluid around them, sink. They fall, slowly, through thousands of miles of hot, dense ocean toward the core. Researchers have actually recreated this in a laboratory, firing intense lasers at the right materials and watching tiny diamonds form in the shockwave. So somewhere down inside that frozen, rotten, sideways planet, there is a permanent, silent storm of diamonds raining through the dark, falling forever toward a center no light has ever touched. The most beautiful thing in the solar system, happening in the most hostile place we know, where no eye will ever see it. Hold that picture, because it captures the whole character of this planet. Everything about Uranus is a contradiction wearing a calm face. A diamond storm inside a frozen hell. A dead-looking marble with weather raging across it. A quiet little world that got violently knocked sideways and never recovered. There's one more thing, and it might be the eeriest of all, because it suggests the damage runs all the way to the planet's heart. Most planets, Earth included, have a magnetic field that runs roughly through the center, lined up more or less with the way the planet spins, pole to pole, like a bar magnet sitting straight inside a ball. It's tidy. It makes sense. Uranus didn't get that.
Its magnetic field is tilted nearly 60 degrees away from its spin axis. And on top of that, it's shoved off-center, not anchored at the core, but offset toward one side of the planet, as if someone grabbed the planet's magnetism and yanked it loose from its mooring. The result is a field that wobbles and lurches as the planet rolls, a chaotic, lopsided, tumbling shield with no clean north and south the way ours has. When Voyager flew through it in 1986, the readings were so strange that scientists spent years afterward just arguing about what they were even looking at. A planet's magnetic field is supposed to be the steady, reliable thing about it, the deep order at its core. Uranus doesn't have that order. The chaos goes all the way down. Whatever struck this planet didn't just tip it over. It seems to have scrambled it from the inside out. And 4 billion years later, it still hasn't found its balance. Here's what I find almost hard to accept. For all of this, the rings, the storms, the freezing, rotten atmosphere, the diamond rain, the broken magnetic field, the 29 moons, we have sent exactly one spacecraft to study it. And that was 40 years ago. We have rovers crawling across Mars, sending back high-definition video every single day. We've flown a probe past Pluto, billions of miles farther out. And yet, for one of the strangest planets in our own solar system, our close-up understanding has been frozen since the year of the first space shuttle disasters and the original Top Gun. That is finally starting to change. A dedicated mission to Uranus, an orbiter that would settle into the system, and a probe that would plunge straight into that hostile atmosphere, has been ranked as the single highest priority for the next great planetary mission. If it gets built and launched, it would still take well over a decade just to arrive. The people who first dream up that mission may be retired before it ever reaches its target. That's the price of admission to a planet this far away and this forgotten. So step back and take in the whole thing, the way Webb finally let us see it. A planet rolling on its side through permanent twilight. The coldest world in the solar system, colder than anything Earth can imagine. An atmosphere that reeks of rot and would suffocate and freeze you in the same breath. A bottomless ocean of crushing, scalding fluid where diamonds rain into the dark. A magnetic field knocked so far off its axis, it tumbles like a thing that's broken. A moon with a cliff so tall you'd fall for 10 minutes off its edge. And vertical rings standing up around all of it like a target. The quiet fingerprint of whatever hit this world hard enough to lay it down for good. For 37 years, we looked at the blue marble and called it dull. We were wrong, and not by a little. It was never dull. It was simply out of focus. And the moment a telescope sharp enough came along, the disguise fell away, and we saw what was actually there. Not a boring planet, a wounded, hostile, magnificent one that had been hiding in plain sight at the edge of everything, joked about and dismissed, while it quietly held some of the most extreme conditions we've ever found anywhere.
That's maybe the most unsettling lesson in all of this. The thing we were most sure we understood turned out to be one of the strangest and most violent places in the solar system. And the only reason we ever found out is that we finally bothered to look closer. It makes you wonder what else is out there that we've written off too soon. The universe doesn't always hide its monsters in the dark corners of deep space. Sometimes it leaves one right out in the open, painted a calm and pleasant blue, waiting patiently for us to stop laughing and pay attention. And one day, hopefully not too far off, we'll finally send something back. A machine built to fall into that rotten, frozen, diamond-filled dark and tell us what's truly down there. When it does, I have a feeling Uranus has a few more secrets left, the kind that ruin your sleep. Thanks for watching, and I'll see you in the next one.